Let us now learn about the concepts of probability. Now, probability is the possibility of an event occurring. Let's understand this with the help of some examples. Let us take three events. The first event being that you draw a card from a deck of playing cards that has the number 11 on it. The second event is that you throw a dice and you roll the number 1. The third event is that the sun will be rising from the east. Now, in terms of measuring the possibility that each of these three happen, they can be categorized differently. Drawing a card with the number 11 on it is an impossible event because 10 is the largest numeric value that a playing card can have. So, given a deck of cards, if you draw a card, it will never have the number 11. Hence, this kind of an event is an impossible event. Now let's look at the event of the sun rising from the east. This event is a definite event because the sun will always rise from the east. Therefore, this is known as a certain event because there is a certainty in this occurring. This has to occur, nothing else can occur. Whereas look at the event in the middle, that is, you have thrown a dice and you have rolled the number 1. When you throw a dice, there can be 6 numbers that you can throw. You can throw any number from 1, 2, 3, 4, 5 and 6. Now, throwing a dice and getting a number 1 is neither impossible because it is one of 6 possible outcomes, and neither is it certain because there are some other outcomes which can also occur. Since this is 1 out of 6 possible outcomes, we say that rolling the number 1 is a probable event, which means that it is possible for you to throw the number 1, but it is not definite. The probability of a certain event occurring is denoted by the small letter p. For an impossible event, the probability is 0. You will never draw a card with the number 11 on it, hence the probability of drawing a card with the number 11 is 0. Likewise, since the sun rising from the east is a certain event, the probability for that is 1. Now we have established this spectrum where something impossible has a probability 0, something certain has the probability 1. So an event which is neither impossible nor certain, that is the event is probable, will have a value that is between 0 and 1. But what exactly is this value? Given that I throw a dice, what value between 0 and 1 denotes the probability that I will throw a number 1? The probability of any event occurring is the number of favorable outcomes divided by the number of all possible outcomes. So if you are throwing a dice, your favorable outcome for which you are calculating probability was that you are throwing the number 1. The number of all possible outcomes means what are the total number of outcomes that are possible when you throw a dice. In this case, it is 6. So the probability of throwing the number 1 is 1, that is the number of favorable outcomes, divided by 6, which is the number of all possible outcomes when you throw a dice. Let's understand it better. You have a bag that contains some blue balls and some orange balls. There are 6 orange balls and 7 blue colored balls in this bag. Now suppose I close my eyes, put my hand inside the bag and take out one ball. The question is, what is the probability that this ball that I have picked up at random is orange in color? That is, if I am at random picking up one ball from amongst these 13 balls, which can be either orange or blue, what is the probability that the ball I have picked up is orange? Now the number of favorable outcomes is 6. There are 13 different balls that I can pick up from this bag, but 6 of them are orange. Therefore, the number of favorable outcomes shall be 6, that is the number of orange balls. Likewise, the number of all possible outcomes is 13 because there are 13 balls in this bag. So there are 13 different ways in which I can pick up one ball. Therefore, the probability that I will pick up an orange ball at random from this bag shall be 6 divided by 13. Apart from this formula for calculating probability, there are two key concepts which you must keep in mind. The first is the and or concept. The second is the not concept. So what do I mean by and or? So when you have more than one event occurring, say you have two events occurring, the final outcome can be a combination of the outcomes of these two events. For instance, if we take the previous bag and ball example, suppose I pick up two balls from the bag. The first ball could be blue and the second ball could be orange. That is an and relationship. That is, I have two events. One is that I am picking up a blue ball. Second is that I am picking up an orange ball. An and relationship is that I am picking up a blue ball and an orange ball. On the other hand, an or relationship signifies that either one of the events or both the events can occur. For instance, if I am picking up a ball from the bag, it can be a blue ball or it can be an orange ball. So if you know the probability of two events A and B occurring, that is, you know the probability that A will occur and you know the probability that B will occur, I will now tell you some formulae which will tell you what is the probability of A and B occurring as well as A or B occurring. So the probability of A and B is the probability of A occurring multiplied by the probability of B occurring. Likewise, the probability of A or B occurring is a sum of probability of A plus probability of B. Let's understand this with the help of an example. So when you throw a dice, there are 6 outcomes as we just discussed. The probability of getting any one number is 1/6. Now if we are finding the probability of getting an even number when we throw a dice, it means that there are 3 desirable outcomes that we are looking at. That is, we are either throwing a 2, a 4 or a 6. So using the above formula, the probability that we throw either 2 or 4 or 6 shall be the sum of the individual probabilities, which shall be 1/6 plus 1/6 plus 1/6, which is equal to half. The second key concept is the not concept. That is, if you know the probability that a certain event will occur, how do you find out the probability that it will not occur? The key idea here is that if it is probable for an event to occur, it is also probable for the event to not occur. Given an event A, and we know that it is a probable event and we know the probability that the event A shall occur, the probability that event A shall not occur is equal to 1 minus probability that A occurs. You can understand this concept, the logic of this concept better with the help of an example. Now when you toss a coin, there are 2 possible outcomes. You can either throw a head or you can either throw a tail. Now the probability that you throw a head is half because there are 2 outcomes and this is 1 out of 2 outcomes. So the probability you throw a head is half and the probability that you do not throw a head is 1 minus half is half. Now if you do not throw a head is the same as throwing a tail. Let us understand the concept of not with the help of an example. The probability of getting a number on a dice is 1/6. So the probability that you will not get that number is 1 minus 1/6. The probability that if you throw a dice and get the number 2 is again 1/6. So the probability that you throw a dice and do not get 2 as the output is 1 minus 1/6 or 5/6. Let us take a look at the different question types that come here to understand how to apply these concepts. The first is regarding and or. The question reads, A deck of playing cards has 52 cards. What is the probability of drawing a red jack? Now all of us are familiar with playing cards. Each deck of playing cards has 4 suits, of which 2 are red. The 4 suits are clubs, spades, diamond and heart. Of these 4, 2 are always red. That is, diamond and heart are always red. Each suit, that is club, spade, diamond and heart, shall have a jack of its own. So each deck of 52 cards shall have 4 jacks. That is the jack of clubs, the jack of spades, the jack of diamonds and the jack of hearts. Of the entire deck, half shall be red. That is, any card that is a diamond or a heart shall be red. So what is the probability that when you draw a card, it is a jack and it is red? That shall be given by the probability that the drawn card is a jack. That shall be given by the probability of the drawn card being jack multiplied by the probability of a drawn card being red, because it's an AND relationship. The probability that the card is a jack is 4 by 52 and the probability that the card is red is 26 by 52. The probability that the drawn card is a jack is equal to the number of jacks divided by total number of cards. The probability that the card is red is equal to total number of red cards divided by total number of cards in the deck. So the probability of the card being both a jack and red is given by this. We know the total number of jacks, we know the total number of red cards, and we know the grand total number of cards. So we can easily calculate the probability that the card drawn is a red jack. Let us now look at a question that deals with the concept of not. Now the English alphabet has 2 types of letters. That is, an alphabet can either be a vowel or a consonant. There are 5 vowels in the English alphabet. Those are A, E, I, O, U. Apart from these 5, every other alphabet is a consonant. So since an alphabet can be only one of 2 things, that is, it can either be a consonant or it can be a vowel, the probability that an alphabet is a consonant is equal to 1 minus the probability of it being a vowel. Since there are 5 vowels, the probability of it being a vowel is 5 by 26. So the probability that a randomly selected alphabet is a consonant is 21 by 26. Let us now look at some important tips and shortcuts for solving probability questions. I shall now be going through some commonly occurring events that are featured in probability questions in IBPS and other competitive exams. These are commonly occurring probabilistic events. So you should memorize the probability of something occurring so that you can quickly solve the question without thinking too much. The first is the concept of a coin toss. So when you toss a coin, you either get a head or you get a tail. The probability of either event is half. The second commonly occurring event in probability questions is the rolling of a dice. Now when you throw a dice, there are 6 possible outcomes as we just discussed. So here we have to know the concept of a biased or an unbiased dice. An unbiased dice is fair, that is, each of these 6 numbers has an equal probability of occurring. However, sometimes if someone is cheating at a casino or something, they would use something called a loaded dice. Now in a loaded dice, the probability that one particular number will be thrown is higher than the probability of the other numbers. That is, all the 6 numbers are not equally probable. Therefore, one important thing that you should look at in a question that concerns dice is that it is an impartial dice, it is not a loaded dice. Now for an impartial dice, as I mentioned, all these 6 numbers are equally probable. The probability of each number being thrown is 1/6. The third event that we shall look at that The third kind of event that features commonly in probability questions is pulling out a card from a deck of playing cards. Now many of us are very familiar with playing cards because it's a very common game, but some of you may not be knowing it properly. So let me explain how a deck of cards looks like. Now a deck of cards consists of 52 cards. There are 4 suits in a deck of cards. If we go through this image, the one on the top is called a diamond. The second one, the black one with 3 circular things, is called a club. Third one is called heart, and the fourth one is called a spade. Now each suit of cards has 13 cards. The 13 cards are ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you have the 3 face cards. That's the cards because they have a face on it, so they're called face cards. You have 3 face cards called jack, queen and king. Now for every number, there are exactly 4 cards. That is, if you take the number 6, there will be exactly 4 of 6. That is a 6 of diamond, 6 of spade, 6 of heart and 6 of club. Similarly for 7, 8, jack, queen, etc. The first card is called an ace. The first card denotes a number 1, but it is called an ace. It will have the alphabet A on it. So now we know that there are 4 suits and 13 different card types. The probability that you have drawn a card from any one suit, that is, the probability that you have drawn a diamond, or the probability that you have drawn a heart, or the probability that you have drawn a spade is 1/4. Because 1/4 of the entire deck is a diamond, 1/4 of the entire deck is a club, 1/4 of the entire deck is heart, and 1/4 of the entire deck is spade. Likewise, the probability that you have drawn a particular number, that is, say the probability that the card you have drawn is a 5, or the probability that the card you have drawn is a queen, is 1/13. That is, exactly 1/13th of your deck is an ace, 1/13th of your deck is a 2, and so on. So these are some key numbers that you must remember with respect to probability questions involving playing cards. So these are some key numbers that you must remember with respect to probability questions involving a deck of cards. The probability of drawing cards of one particular suit is 1/4. The probability of drawing one specific card from this deck, like say the probability of drawing the 8 of hearts, shall be 1/52. Likewise, the probability of drawing a particular number, like the probability of drawing an 8 or the probability of drawing a king, shall be 1/13. Now most decks of cards come with 2 additional cards called a joker. Now the joker cards are normally excluded from probability questions in competitive exams. But you must be aware and not get confused if a question involves a deck of cards with a joker. So now if you add the 2 joker cards, your total deck size increases from 52 to 54. Therefore, the probability of you drawing any one suit becomes 13/54, and the probability of you drawing any particular number becomes 2/27. So the key numbers to remember here are probability of drawing any one suit is 13/54. Probability of drawing one specific card is 1/54. Now this is with the exception of the joker, because there are 2 identical joker cards. The probability of drawing a joker shall be 2/54. And the probability of drawing a particular number shall be 2/27. The next tip that I am going to provide you is replacement. Remember the example of the bag that contained blue balls and orange balls. Now say we have to pick 3 balls out of this bag. There are 2 ways in which I can do this. First is with replacement. What that means is, I reach into the bag, pick up a ball, I see what color is it, and I put it back into the bag. Then I pick up the second ball, note the color, and put it back. Then I pick up the third ball, see what color it is and put it back. That is, I'm picking up a ball from the bag and replacing it. The second way of doing it is without replacement. That is, I reach into the bag, pick up one ball, keep it outside. Then reach into the bag again, pick up the second ball, keep it outside. Reach into the bag, pick up the third ball and keep it outside. Therefore, there is one important thing that you must take note of. if the problem involves replacement or specifically says that it is selection without replacement. Now if we are picking balls with replacement, when I'm picking the first ball from the bag, there are 13 balls in the bag. Then I go and pick up one ball. I then replace the ball. I put the ball back. When I'm picking up my second ball, again there are 13 balls in the bag. So I pick up a ball now, see it and put it back. When I'm reaching in to pick up the third ball, again there are 13 balls in the bag. So again I pick the ball up, look at it and replace it. If I'm doing this without replacement, before my first pick there are 13 balls in the bag. So then I reach into the bag and pick up my first ball. This is without replacement, so I don't put it back. Now, when I'm going to pick up my second ball, one of the balls has already been taken out of the bag. So there are only 12 balls in the bag. So when I'm picking up my second ball, I'm choosing 1 out of 12 balls. So I pick up 1 out of 12, keep it outside and don't put it back. So now when I'm going to pick up my third ball, I have already picked up 2 balls and kept them outside. So there are only 11 balls in the bag. So again I reach in, pick up 1 ball out of 11 and do not put it back. So this is what you must be aware of. If the problem has replacement, the total number of objects from which you are selecting shall remain constant because you shall select something and put it back. So your total number of choices remains the same. On the other hand, if there is no replacement, each time you select something, your base will keep shrinking. The number of objects that you can choose from keeps shrinking. So you must ensure that in a problem without replacement, the denominator in your probability will keep reducing. That is because the total number of outcomes is also reducing. In the first case, the total number of outcomes is 13. In the second case, the total number of outcomes is 12. In the third case, the total number of outcomes is 11. So this ends our lecture on probability. We have covered those aspects of probability that are important from the bank exam point of view. The topic of probability otherwise is vast and immense with many applications in engineering, computer programming and so on. But for our need, Course Mantra has condensed those concepts of probability which you will require for the quant section of your IBPS exam. Sufficient practice of different types of questions from sample problems or sample papers will help you grasp this concept properly.